Welcome to another intermediate algebra video. In this video, we're going to look at a few more aspects of graphing quadratic functions. So our objectives, there's only one in this case, but it has a few different pieces to it. So we're going to look for the vertex, which we've seen how to find in the previous video. The intercepts, we haven't looked at that with quadratics yet, but we already have looked at intercepts before. The direction of opening, this will be a pretty simple analysis. The maximum or minimum value of the quadratic, and then graph the quadratic function. So there'll be 5 things we identify for each problem. It's not always going to be the case that you're asked for all 5 of them. Sometimes just one, sometimes this, sometimes all 5 of them. But we're going to do each one for every problem so you have the practice of finding each one. Okay, so our notes. These are the quadratic function forms. These two are. We have vertex form, which is the form we saw in the last video. And then standard form, which we've seen previously throughout the semester. So one of the things we're looking for is the vertex. If it's in vertex form, well, then the vertex is pretty much handed to us. It is the h, k value. If we're given the problem in standard form, which we've seen before, ax squared plus bx plus c would have to be in this order, then this is the formula for the vertex. It looks complex, but I promise you it is not. So the x-coordinate, if you can get the x-coordinate, then you're good. The x-coordinate is negative b over 2a. Negative b, this b value, over 2 times a, whatever that a value is. You'll do some work and you'll come up with a number. Once you have that number, all you have to do is find the corresponding y value. That's all this says in math notation. Plug in whatever number you got here and find the corresponding y value. Corresponding y value. So you do need to know this, negative b over 2a, but you do not need to memorize the other piece of this little formula for finding the vertex. And then a last note here is our maximum or minimum value. This simply is going to be the y-coordinate of the vertex, and here's why. So let's say our graph looks something like this. We don't exactly know what the coordinates are. Sure, we can say we know what the coordinates are. Our base is at 1, 1. We're looking for the maximum or minimum value. So simply the highest or lowest point. Well, in this case, which does this have? Does it have a highest or does it have a lowest point? The highest, it goes on forever, so there's no highest, but it does have a lowest. So this one has a minimum value. And that minimum value is what? What's the lowest place it goes? If you're talking about an up or down movement, which coordinate are you looking at? Y is your up and down movement. So it is simply the y-coordinate of the vertex. The lowest place we go is this y value. So a minimum value of 1. And it works the other way as well. If you had a graph that had been reflected, so it was facing down, your vertex, you could still identify, but then your max-min value, maximum or minimum value, in this case you have a maximum value because there's a highest spot that this graph goes, and let's say it's 0, -1, would be -1. So the highest place that graph goes is -1. I feel like there was another thing I wanted to say. It is escaping me. The relationship between vertex and standard form, if you wanted to, you could always move from one to the other. To go from vertex to standard form, you would simply expand using FOIL, distribute the A, combine like terms. You would turn your problem into standard form. And if you took standard form and completed the square on it, you would have vertex form. A little modification, a modified version of completing the square, you could get back to vertex form. You do not ever have to do that, at least for what we're looking at right now. But if you wanted to, you could always make the change and then assess all of the questions from there. So we'll look at vertex, axis of symmetry, not axis of symmetry, intercepts. We've seen how to do that. Direction of opening, which very simply, this one opens up and this one opens down. You can look at the graph for that. Find the maximum value and then graph the quadratic. So let's actually put these things into practice. So the first question, find all 5 of these things. We're going to find, let's go with red, the vertex, the intercepts, the direction of opening, the max or min value, and then we're going to graph the quadratic function. Okay, what form is this problem in? Is it presented in vertex form or standard form? This one is in vertex form, which will help us identify the vertex pretty easily. The vertex is your hk value, so our h in this case is 2, our k is -6, so the vertex, -2, 2, as h is 2, -6. There's your vertex, 1 thing down, 4 to go. The intercepts. Intercepts are the places that it crosses on the x-axis and y-axis. So you plug in 0 for each at a time. Let's start with our x-intercepts and solve for the other. If we plug in, if we want x-intercepts, we plug in 0 for which one? Do you remember? If we're looking for x-intercepts, we want there to be a number for x, so we plug in 0 for y. All right, so let's plug it in. We get 0 equals x minus 2, quantity squared, -6. This is one part of the problem, finding the intercepts, where you may have a good amount of work to do. Vertex is a pretty easy analysis, direction of opening, pretty simple, maximum value, simple, graphing, hopefully is simple once we have these intercepts. So this is the problem we have to solve. Well, there's a few different ways we could solve this. This one's already set up to solve using the square root, so let's add 6 to both sides. Whoops. We have 6 equals x minus 2, quantity squared. Then we'll take the square root, which will give us square root of 6, equals x minus 2. Don't forget, put the plus minus in front of that square root of 6. Let's bring this up here to keep going. X minus 2. And then to continue solving, add 2 to both sides. It's not necessarily going to combine with that radical, but it'll at least give us the value. So this is what x must be equal to 2 plus root 6 or 2 minus root 6. But we're looking for an ordered pair if we want x-intercepts. So let's write these as ordered pairs, 2 plus root 6, comma 0, and 2 minus root 6, comma 0. If your homework system is asking you to type in intercepts, this is exactly what you're going to type in. If you're graphing this by hand, you need to know what that number would be. So I'm going to get an approximation for each of these. 2 plus root 6 looks like about 4.4, comma 0. And then if it's 2 minus root 6, about -0.4, comma 0. These are approximations, and like I said, the homework system would want these exact values, but for our purposes of graphing this by hand, at the end of the problem, we need to have an idea where those points fall. So let's circle these, because these are the more important. Okay, so those are our x-intercepts. We now also need the y-intercepts. This is the continuation of this second piece. For y-intercepts, we plug in 0 for x. So we have y equals 0 minus 2, quantity squared, minus 6. 0 minus 2, -2. -2 squared, 4. 4 minus 6, -2. This, as an ordered pair, would be 0, -2. Those are all the intercepts. Okay, we're looking also for direction of opening, max-min value, and graphing the quadratic function. Let's do direction of opening after we have the picture. It'll probably give you a good idea once we draw the picture. Max-min value, let's go there next, can be assessed a couple different ways from the picture, or it can be assessed from the vertex. You can kind of figure that out from the vertex. So how do we know if it's a max or min value? What does the standard picture look like? The standard graph opens up, right? The standard graph would have a minimum. So does this graph have a modification that would cause it to reflect? There's no negative on the a value, so it's still up, which means this one has a lowest point. It has a minimum. This can also be made once you have the graph. And the minimum value, it's always the y of your vertex. So it's a minimum value of -6. The third one I'll list up here, but let's go ahead and come up with the picture. Now, you can use the calculator, but we already have enough information to not need the calculator. We know the vertex is 2, -6. We know there's an x-intercept at 4.40. Let's do this in red with the dots. So here's our vertex. There's one at 4.40, there's one at -0.40, and there's also an intercept at 0, -2. Well, there's a good idea of what the picture looks like. You know it's a quadratic, so it'll have this standard U shape. There should be a curve U at the bottom there, which allows us to answer question 3. Does this open up or down? Pretty easily, it opens up. And then again, if you wanted to look at max-min value at this point, you could say it definitely has a minimum value, and that lowest spot is always your y-coordinate of the vertex, -6. So there's all the pieces. This was a problem looking at all 5 things using vertex form. Okay, so let's do the same thing with a problem in standard form. We still want all 5 of those same pieces. I'll label them all. Let's number them. We'll look for vertex, intercepts, direction of opening, max-min value, and then we'll graph. Let's start with vertex. This is in standard form. So to find the vertex, this is the general. We need -b/2a and then the corresponding y value. The note says this. You do not need to write this. You don't even need to write any of this that I have written here. So the x value of your vertex is -b/2a. What's our b value? -2 over 2 times a. What's our a value? A is always attached to the x squared. It's a 1. Minus negative is 2 over 2, which is 1. So the x coordinate of your vertex is 1. Okay, you need the corresponding y value. So y must be 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3. -4. So the vertex is 1, -4. Whoops. Too fast. 1, -4. There's one piece of information. We have the vertex. Okay? Next, we need the intercepts. Let's start with x-intercepts. Remember, this is where you plug in 0 for y. So 0 equals x squared minus 2x minus 3. Okay, take yourself out of all the different crazy things that we're doing. This is what you're focused on solving right now. 0 equals x squared minus 2x minus 3. What strategy can you use here? If you want, you could complete the square. That would take quite some time. You could use the quadratic formula. That would work. If it factors, fantastic. In this case, it factors. So I'm going to go that route. If using quadratic formula is the thing that pops to your mind, go for it. You will get the same answer that I'm getting here. But if it factors, that's much easier. So this one factors to x minus 3 times the quantity x plus 1. Then solve each of these individually. We get x equals 3. And x equals -1. Each of these as ordered pairs is 3, 0, and -1, 0. Okay, then we also need the y-intercepts. Y-intercept is plugging in 0 for x, so we have y equals 0 squared minus 2 times 0 minus 3. So y equals -3. As an ordered pair, 0, -3. So we have these two, and we have this one. We have all three of our intercepts. It's not always the case that there'll be 3. If you get to a point where you're doing x-intercepts and you get something that doesn't work, it means that there aren't x-intercepts. It could be possible for a graph, right, to have shifted up this high and never crossed the x-axis. So if you get to a point where you can't solve anymore, then that means there are no x-intercepts. You will always have a y-intercept though. Okay, so we have vertex. Am I still on? Good. We have intercepts. We want direction of opening, max min value, and graph. So let's go ahead and do the graph next, especially now that we have all of these points we can plot. Put some tick marks. And then we'll do this in red. So our vertex is at 1, -4. Our x-intercepts are at 3, 0, and -1, 0. And y-intercept, 0, -3. So again, you get a good idea of what this picture looks like. Knowing which one is the vertex can be helpful. You know that's either where it's going up or going down from. So if everything else is above, then it must go this way. Which answers our questions for number 4 and 5. Our max or min value, do we have a max or min value here? In this case, we have a minimum. We have a lowest spot. And that lowest spot is what? -4, right? K-value of your vertex. And then our direction of opening, pretty simply, is up. You could get this direction of opening from the picture or from the equation. If you look at the A value, a standard A of 1 says that the graph is opening up. So if there's not a negative there, it's going to stay the same. Maybe it's moved, maybe it's wider, maybe it's narrower, that's okay. If there was a negative there, it would reflect. Who cares where it moves? It's still opening down. So you can use the A value to answer that question, or you can look at the picture. But this answers all 5 of those questions. Vertex, intercepts, max min value, direction of opening, and then ultimately the graph, putting all of it together in the same picture. All right, so let's go ahead and do a practice problem of this type. I think I only have one. Yes. So go ahead and find the same 5 things for this problem. Vertex, intercepts, direction of opening, max min value, and graph the quadratic function. All right, let's see if our work lines up. I'm going to label them all again. This is my strategy to stay organized. Okay, first the vertex. This one's in standard form. So I'm going to have to use negative b over 2a to get the x value. Negative, my b is -4 over 2 times my a is 1. Which gives me a 2. Then the y coordinate, plug in that 2. We get 4 minus 8 minus 12. Whoops. So the vertex, 2, negative 16. Good. One piece of information. Okay, let's go to the intercepts next. X-intercept, plug in 0 for y. Again, whatever strategy you want to use to solve this problem, totally fine. I'm going to go with factoring. So in this case, it does factor. X minus 6, x plus 2, which gives us 6 and negative 2. So the ordered pairs, 6, 0, and negative 2, 0. And then your y-intercept is simply plugging in 0 for x, which gives negative 12. So this ordered pair, 0, negative 12. In this case, we found 3 intercepts. Like I said, not always the case. We have vertex, we have intercepts. Let's answer direction of opening and max-min without the graph. The direction of opening, the standard looks up. Our A value is still a positive, so it's still going to be opening up. Our max-min value, if it's opening up, then it must have a lowest location, so it has a minimum. And that minimum value is always the y in your vertex, so negative 16. And then we can prove all of that to be correct when we draw the graph. Looks like we go as low as negative 16. 16, good. Won't need to go out too far. And then let's put all these pieces together. So our vertex is 2, negative 16. Our intercepts, 6, 0, negative 2, 0, and 0, negative 12. So this connects this way. And as we can see, it does open up, and it has a minimum value of negative 16. So to review, everything in this section was, we looked at all 5 of them on every problem, but you may only be asked about individual pieces for specific problems that you're looking at. So vertex, intercepts, which was not too much of a new concept here. Direction of opening, pretty easy to identify, especially from the graph. Max-min value, not too difficult. And then pulling all the pieces together on the graph. I'll see you soon for another video.